In this video, we're going to find out what is the graphical representation of work. So if you're given a graph of force versus displacement, how do you find work from it? In the first 2 to 3 minutes, we'll find out what feature and how to do these types of problems and where do these equations actually come from that we need to use. And in the rest of the video, we'll just watch a really quick one graphical problem. Okay, so let's start by analyzing the equation for work. As before, our equation for work is force times displacement times angle between them. For these graphical examples, we'll just assume that force is in the same direction as displacement, so the angle between them is 0. Basically simplifying this equation, right? Because cosine of 0 is 1. Simplifying this equation to force times the displacement. Now, let me introduce you to a very simple graph. Let's say you have a force of 5 newtons that is being applied over a distance of, let's say, 10 meters. Let me ask you, if the force is 5 and the distance is 10 meters, what is the work done on this object? So hopefully you said 50, right? Because work is simply force times distance. So 5 times 10 is equal to 50. Remember, the units of work are joules. Now, what is the graphical representation of work then? If you take a look at this, the area underneath the curve will be equal to work, right? Because this side is 5, it's a rectangle. This side is 10. So if you find the area of this is going to be 5 times 10 or 50. So in other words, work is the area under the force versus displacement graph. So when you're asked in the questions, right, to find work, this is how to do it, is to find the area. Now let's practice this really by introducing a really quick example. So in this problem, we'll need to find out the total work done on the object, right? And we're given a graph of force versus displacement. So of course, what we need to do is we need to break down this whole graph, right, into pieces, into essentially triangles and rectangles. So we're going to turn it into a really into just a geometry problem. So let's start from over here. This first area right here is going to be, now the area of, let me write this here, the area of triangle, right, is 1/2 base times height. So 1/2, the base is 2 times the height, that is 20. So, or 1/2 times 2 is 1, 20. So 20 joules on that first basically leg. Okay, this next part right here, by the way, feel free to pause the video, right, and practice this concept by trying to identify your own area and then scroll back to see if you get the same answer. Or just keep watching the video and as we calculate the area, this area right here of this triangle. So this side right here is going to be 6 minus 2, so 4. And this side right here is 20. So 4 times 20 will give us 80 joules. All right. Now what about this third right here? So it's going to be 1/2 times base times height. So this side right here is 1, the base, and the height is 20. So times 20. So it's 1/2 of 20 or just 10 joules. Great. Now here's a little interesting side comment, right? Right now we're moving underneath the x-axis, which means that this work will be actually negative. Because remember, work is a vector, so it can be positive or it can be negative. So the area of this fourth area right here, let me label this A3, is going to be 1/2. This is 3, right? Times negative 15. So therefore the area is going to be 15 times 3 is going to be negative 45 over 2 or negative 22.5. The area, final area of this is going to be 2, this side right here, times negative 15 or negative 30 joules. So the final answer of calculate the final work that is being done is just going to be a sum of all of these areas, right? So 20 plus 80 plus 10 minus 22.5 minus 30, right? And notice again that work can be positive or negative. That's also an important takeaway. Because area right underneath the curve can be positive or negative. So let me just calculate this really quickly. So this is 100, right? 110 minus, let me do minus 30 first. So it's going to be 80 minus 22.5. So 67.5, if I'm not mistaken. Let me see. 57.5, sorry. Joules as our final answer. So, all right, guys, so this is pretty much everything you need to know about these types of questions, and keep practicing and keep watching these videos on your way to an A. Thank you.